So ionic solids, this is where we're going to use those unit cells that we looked at earlier. But what's different here is that we're going to have two different kinds of ions in the unit cell instead of a single kind of atom. And so then the coordination number represents the number of close cation-anion interactions. So crystal structures of ionic compounds are a little bit tricky because they have to balance coordination number, charge neutrality, and different ion sizes. So this is cesium chloride. We've got the chloride ions at the corners here and a cesium atom in the middle. It's easy to look at that and think, well, that's a body-centered unit cell, right? Because there's this atom in the middle, or ion in the middle. But here the different colors represent different kinds of elements. And the unit cell is looking at just the one kind of element. So here we've got the four corners. This is a simple unit cell. So inside of this unit cell, we would have an eighth of each of these 8 chloride ions and the one cesium ion. So it would have one of the ion that's sitting at the lattice points. And how do you know how many of the others? Well, charge balance. The formula is CsCl. For every one chlorine, there's one cesium. So if this unit cell contains one chloride ion in total, it must have one cesium atom also. This is sodium chloride. If you didn't have to worry about charges or neutrality or anything, you could fit a lot more of these sodium atoms into the spaces between the chloride ions. But what kind of a unit cell is this? Just look at the green ones, not at the purple. What's in the middle of this face? This is face-centered cubic unit cell. And the the sodium ions are in between. So this is face-centered. How many chloride ions are in the face-centered unit cell? There's half here and half there, that's 1. And that guy is 2. And this guy and that guy is 3. Plus the corners make 1, so 4. So there's 4 chloride ions in that unit cell. How many sodium ions must there be? 4 also. I find it really hard to look at that and count because, it's like, okay, well, what is that, a fourth of that or an eighth? It's just complicated. Just look at the unit cell and then match the other ion based on its side, on the charge. This is called a rock salt structure. And this is what happens when you have ions with different sizes. So this is different than this one, where they were similar in size. And if you get even larger size difference, you can end up with this. This is called the Zinc Blend structure. But again, looking at the unit cell, look at the sulfide ions. There's one face, and here is an atom in the face, right? So this is face-centered cubic unit cell, but the zinc ions are in different places within that compared to these guys, right? So these guys are sitting in what's called a tetrahedral hole. So they're in the holes formed by 4 of the sulfur ions. Come on. Here we've got a 1-to-2 cation-anion ratio. And this is known as the fluorite structure. Again, what's going on here? Well, I'm going to look at this time the calcium ions because that's what they're showing at the corners. So that's a face, and this is again centered on the face. So it's a face centered, and then the fluoride ions are in tetrahedral holes. So it's face centered using the fluorides. Using the calcium. So then how many calcium ions are in there? 4, right? 4 calcium ions. How many fluoride ions? 8. For every calcium, I need 2 fluorines, so then the fluorides there's going to be 8 of them. Counting the number of ions in a structure like this is something that could show up in the final exam, ACS exam.